Hello viewers, welcome to Chemistry Pathsala. In this video lecture, we are going to discuss reaction intermediate part 2. So let's get started. So now you have to find out the stability of carbocation. In case of P, it is stabilized by mesomeric effect. In case of Q, it is stabilized by resonance. In case of R, it is stabilized by hyperconjugation and because of 2 alpha hydrogens. And in case of S, the carbocation stabilized by dancing resonance. And you know very well that mesomeric effect dominates over dancing resonance, and dancing resonance dominates over your resonance, and resonance dominates over your hyperconjugation. Therefore, P greater than S greater than Q greater than R. Okay, so this is your answer. Coming to the next slide. Now, in case of P, it is stabilized by mesomeric effect. In case of Q, it is stabilized by your hyperconjugation through 4 alpha hydrogens. In case of R, it is stabilized by your resonance. So phenyl group will show the conjugation, or you can say this is resonance phenomenon. And S is, yes, it shows aromaticity. Therefore, mesomeric effect dominates over your aromaticity, aromaticity dominates over resonance, resonance dominates your hyperconjugation. So what is your answer? P, then S, then R, then Q. Okay, so P, S, R, Q is your order. Coming to the next slide. Okay, P is stabilized by resonance and Q is stabilized by mesomeric effect, but you have to think very careful the difference between Q and R. Both are stabilized by mesomeric effect, but the thing is that here there is possibility of cross conjugation is there, where in case of R there is no such case. So that means here mesomeric effect with cross conjugation. Here only mesomeric effect. That means between these two, obviously the R is more stabilized carbocation than the Q having the carbocation. In case of S, you will find out here 3 alpha hydrogens, here 1 alpha hydrogen. So it is stabilized by hyperconjugation. That is because of 7 alpha hydrogen. In case of T, it is stabilized by, yes, very good, it is stabilized by 5 alpha hydrogens. 5 alpha hydrogens, correct? So you know very well that mesomeric effect dominates over your resonance and resonance dominates over your hyperconjugation. So you have 2 types of mesomeric effect. One is without cross conjugation and with cross conjugation. Cross conjugation decreases the stability of carbocation, right? So therefore R is more stabilized than Q. And similarly, in case of resonance, there is only one possibility is there, and that is P. And in case of hyperconjugation, you have 2 possibilities there, one having 7 alpha hydrogen, one having 5 alpha hydrogen. And you know that hyperconjugation directly proportional to number of alpha hydrogens, right? So the 7 alpha hydrogen, that is S, and that is T, 5 alpha hydrogen in case of T. So the stability order is RQPST. RQPST. Okay, so coming to the next slide, question number 4. Yes, can you find out this question? Yes, so it just looks like this. So now this is breeze head carbocation. Okay, in case of Q, it is stabilized by your hyperconjugation. So how many alpha hydrogens are there? 1, 2, 3, 4, 5, 6 alpha hydrogen, correct? So this is 6 alpha hydrogens. And in case of R, how many alpha hydrogens are there? You can clearly mark there 9 alpha hydrogens are present there. In case of S, yes, very good. So it is anti-aromatic compound. Okay, so you know that the hyperconjugations having 9 alpha hydrogen dominates over the hyperconjugation having 6 alpha hydrogen. And you know that between bridgehead and anti-aromatic compound, the bridgehead slightly more stable as compared to anti-aromatic compound, but both are having unstable carbocation. Yes, both are having unstable carbocation, but bridgehead slightly more stable as compared to the carbocation in case of anti-aromatic compound. So the answer will be 9 alpha hydrogen in case of R and 6 alpha hydrogen in case of Q, and bridgehead in case of P, and anti-aromatic compound in case of S. So R, Q, P, S is your answer. R, Q, P, S. Clear? Now question number 5. Now you can find here there is CS3 here and CS3 here. That means you have stability of this carbocation because of the hyperconjugation, that is 6 alpha hydrogens. 6 alpha hydrogens. Here in this case there is 3 alpha hydrogens, right? In case of R there is no alpha hydrogens. Okay, and if you are thinking of resonance, yes, in both the case similar, or you can say same type of resonance. So resonance cannot be the factor to determine their stability, only determination because of this hyperconjugation. You can say this RH, RH, or R only, right? Only resonance, correct? So the stability will be P greater than Q greater than R. Okay, this is your answer, correct? Now coming to the next slide. Okay, in this case now you have to show the resonance so that your confusion will be cleared. Here there is no resonance, no resonance. It will be stabilized only by hyperconjugation. Only by hyperconjugation is there. So resonance is not there. In case of Q, let us draw the picture. What you will get? You will get 3 alpha hydrogens. So it is stabilized by resonance and 3 alpha hydrogen, and it is stabilized by your resonance is there and there is alpha alpha, so it's stabilized by resonance and 6 alpha hydrogens. Okay, here hyperconjugation is stabilized by 2 alpha hydrogens. So neither hyperconjugation nor resonance will determine the stability of R. So the stability will be P greater than Q greater than R. Okay, here both, in case of P and Q, both resonance and hyperconjugation there. In case of R, only hyperconjugation is there. Okay, and P is dominate over Q because of more number of alpha hydrogens than Q. 3 alpha hydrogens. Clear? Now question number 7. Now question number 7, in question number 7 you find resonance is there in case of P. In case of Q, resonance is there, and here you can find out 3 alpha hydrogens are there. So it is stabilized by hyperconjugation. Now in case of R, there is also possibility of resonance is there, and also you will get, yes, 6 alpha hydrogens. So more number of alpha hydrogens, more stable is the carbocation. So the answer will be R greater than Q greater than P. Clear? Now coming to the next question, question number 8. Yes, it's a very interesting question. Okay, so CS3 group is there, CS3 group is there, no CS3 group is there. So you can do the structure like this. This is double bond CS2, and you will find out this structure like this. Okay, so you will get this structure like this, and you will get a positive charge here, double bond here, and CS3 is there. Okay, so it shows resonance and it shows inductive effect plus I effect at para position. Okay, in case of Q, okay, see here, in case of Q what is happening here. So in case of Q, this is CS2 and positive charge is there. Okay, this is CS3. Okay, this is ortho position, right? Now if you draw another regenerating structure, what you will get here, just a second. Okay, yes, so when you draw the regenerating structure, what you get here, you get positive charge here and C double bond CS2 here, and this is para position. But the presence of your CS3 group at meta position, that means there is no formation of carbocation at meta position. Okay, so carbocation not formed at meta position, but carbocation formed at ortho position and your para positions. That means the stability of carbocation depends upon the groups present at ortho and para position, right? So in case of this two case, in case of P and Q, you find out that this CS3 is acting as plus I effect here, but since there is no formation of positive charge in case of meta position, so it will be less stabilized as compared to the CS3 group present at the para position, because it stabilizes the carbocation at para position. So clearly P greater than Q. Now in case of R, yes, resonance is there. In all the three cases, resonance is there, right? In case of P and Q, resonance is there plus I is there, resonance is there plus I is there, but in case of R, only resonance is there. So in case of P and Q, since the carbocation stabilized by two factors, so it's obviously dominates over R. Okay, so the order will be P greater than Q greater than R. I think your confusion cleared. Okay, next, coming to the next slide. Now in case of this carbocation, okay, now yes, very good, very good. You are thinking of mesomeric effect. Before that, just do the resonance so that you will get proper idea of mesomeric effect there. Okay, now you will see, you will get mesomeric effect. Now you are happy, right? In case of this, you will get and positive charge here. In case of this, you will get like this. Got it? Now the thing is that here you will find alpha hydrogens there, here you will find alpha hydrogens, here you will find alpha hydrogens. So if you calculate in both the cases, they are regenerating stabilized, they are regenerating stabilized. That means you can simply say they are stabilized by resonance. But the thing is that the extra factors which differentiates between P is the more stable carbocation because of the mesomeric effect. Between Q and R, you will find out hyperconjugation is the common factor, but the difference is that here number of alpha hydrogens are 6 alpha hydrogens, but here the number of alpha hydrogens are 9 alpha hydrogens. Therefore, you will find out the stability of carbocation P is dominant over your R and R dominant over your Q. So this is your answer. Coming to the next slide, question number 10. Now you have to draw the regenerating structure so that your confusion will be cleared out. So if you do the resonance here, okay, did you find any difference or did you find any chance of mesomeric effect? Of course no. So that means it will show only resonance. In case of Q, if you draw a regenerating structure, you will find out the formation of carbocation here so that it will show mesomeric effect. Obviously resonance is there, so it will show mesomeric effect. But in case of R, remember R, there is no possibility of resonance. There is only hyperconjugation is there because of this 2 alpha hydrogens. So obviously mesomeric effect dominates over your, obviously your mesomeric effect dominates over your resonance, and your resonance dominates over your hyperconjugation. So what will be the answer? The answer will be Q, yes, greater than P greater than R. Yes, cleared? Coming to the next slide. Got it? Okay, so this is the question. Now alpha hydrogens are there, alpha hydrogens are there, alpha hydrogens are there. Got it? Now it's time to distinguish all the carbocations by the resonance. Okay, so you will find out that this carbocation shows the mesomeric effect. So now it's useless to consider the hyperconjugation. If you see the hyperconjugation, you will find out 2 alpha hydrogens are there, because since you cannot find out any kind of mesomeric effect in case of Q and R, therefore you just say that yes, P is only the case having more stabilized carbocation because of mesomeric effect. So P will dominate over Q and R. Okay, now in between Q and R, you have to check very carefully. We will find out, yes, we'll find out there is possibility of this resonating structure. Just a second. Okay, okay, I think you got answer very quickly. Okay, you find your resonating structure like this. That means your new alpha hydrogens are like this. So there is, how many alpha hydrogens are there already? Here there is 2 alpha hydrogens, here there is 3 alpha hydrogens, here there is 2 alpha hydrogens. So total number of alpha hydrogens are 3 to 5 to 7 alpha hydrogens. So it is stabilized by resonance, and your 7 alpha hydrogens are there. In case of R, what you will find? You will find that because of this resonance, the formation of new carbocation is there, and you will find out this alpha hydrogens are there. So it is stabilized by resonance obviously, and hyperconjugation before of 4 alpha hydrogen. So what is your answer? Obviously mesomeric effect dominates, and in between Q and R, resonance there, that is common is there, but the differentiate because of alpha hydrogens. So the answer will be P greater than Q greater than R. Okay, clear? Now coming to the question number 12. Now, yes, this is at the para position, this is at the para position, this is the meta position, this is the meta position, and already we discussed this question. So you know very well that there is a possibility of formation of carbocation at para position. So you can easily determine this is OMe, right? And in this case you can find out the same phenomenon, the carbocation formation at para position. In this case obviously you will struggle for your carbocation at meta position, and similar case here. Okay, I am showing you in shortcut manner so that it will be easier for you. Now this carbocation will stabilize by your mesomeric effect. This carbocation will stabilize by plus I effect. Now in this case this carbocation will be destabilized because of this minus I effect. You know that OMe can show you mesomeric effect and it can show you minus I effect also. Can you find any stabilization at meta position? Obviously no. Now here in case of P and R, the difference is that it is showing you mesomeric effect, right? In case of P it is showing you mesomeric effect, in case of R it is showing you minus I effect. This is the basic difference, right? And in case of S it is showing you plus I effect, right? But in case of P and S, you know very well that the carbocation formation at para position is more stabilized by this plus I effect as compared to the plus I effect in case of S. Clear? So the answer will be mesomeric effect, right? So the answer will be first P greater than, yes, Q greater than S greater than R. Yes, P, Q, S and R. Clear? Question number 13. Now here alpha hydrogens are there, here alpha hydrogens are there. Okay. Now by resonance, so what you will find? By resonance you will find out the formation carbocation there. So new alpha hydrogens are there. Total number of alpha hydrogens are 3, here 2, here 2. So resonance and hyperconjugation by 7 alpha hydrogens there. In this case alpha hydrogens and alpha hydrogens are there. So there is 3, 3 and 1. Now by resonance the new carbocation formation will give you more number of, yes, very good, more number of alpha hydrogens. Cleared? Okay, just a second. Okay. So there will be no resonance. Actually there will be no resonance. So there will be only hyperconjugation. Okay. So this is alpha hydrogen, this is alpha hydrogen, this is alpha hydrogens, and there is alpha hydrogens, there is alpha hydrogens. So it will be stabilized by resonance. Okay, stabilized by resonance. Okay, and in this case you will find out new alpha hydrogens present here. So how many alpha hydrogens you will get? So there is 2 alpha hydrogens, 3 alpha hydrogens, and there is 2 alpha hydrogens. Correct? So 3, 2, 5 to 7 alpha hydrogens, and there is possibility of resonance also there. So resonance and hyperconjugation. In this case there is no such case, there is no resonance is there. Okay, so I was checking the question. Yes, the question is correct, and there is no formation of resonance is there. So it will stabilize by only hyperconjugation. How many alpha hydrogens are there? 3 and 1. The hyperconjugation only by 7 alpha hydrogens are there. In this case you will find out resonance is there, and you will find out already alpha hydrogens are there. So already 2 are there, 2 alpha hydrogens are there. Now because of this resonance you will find out new alpha hydrogens are there. So resonance is there, hyperconjugation is there, hyperconjugation because of the 4 alpha hydrogens. Yes. So what is your answer? What is your answer? So the answer is the P greater than R greater than Q. P greater than R greater than Q. Yes, because in case of P it is resonance and hyperconjugation, and in case of R this is resonance and hyperconjugation. In case of Q there is possibility of only hyperconjugation. Correct? So P, R and Q is your answer. Cleared? Now coming to question number 14 there. Okay, now in case of 14, okay, you find out alpha hydrogens are there, alpha hydrogens are there, alpha hydrogens already there. Okay, alpha hydrogens are there and alpha hydrogens are there already 2. Okay, so this is 2 and this is 3 and this is 2. Correct? Okay, now in this case what is happening here? Now you make a resonance here. So what you get? Yes, correct. So you get another new alpha hydrogen. So this is 2, this is 2. So this is stabilized by resonance and hyperconjugation. Number of alpha hydrogens are 6 alpha hydrogens are present here. In this case you will find out, because of resonance you will find out new resonating structure is like this. Correct? So you get carbocation here, and there is no possibility of new alpha hydrogens because this carbon is having carbons, so there is no presence of alpha hydrogens. You can clearly observe this one. Okay, so it will be stabilized by resonance and hyperconjugation through 2 alpha hydrogens. So now in this case, because of this resonance, you will find out new resonating structure, and it will be like this. There is formation of carbocation there, right? So now you will find out new alpha hydrogens. So this is 2, this is 2. So already 3 there, 2 plus 5 and 2 plus 7. So total it will be stabilized by 7 alpha hydrogens are there. Correct? Now in this case, yes, very good, very good. Correct. Yes. So it will be stabilized by mesomeric effect. Yes. So forget about the alpha hydrogens. Yes, you can take it also. So here it will be stabilized by mesomeric effect and hyperconjugation. If you consider, then it will having 2, and this is having your 2 already there. So 4 alpha hydrogens are there. Okay. So the answer of this question will be mesomeric effect dominates over resonance and hyperconjugation. And in these 3 cases, you will find out resonance is there, hyperconjugation is there. So resonance is common here. Okay, so there is no possibility of extended conjugation. So resonance is common there, or you can say similar type or same type of resonance is there. Now the difference is in between the hyperconjugation. So the number of hyperconjugative structures is more in case of R as compared to Q and P, because it is having 7 alpha hydrogens there. So R will be greater than, then S will greater than R, then R will greater than your P, and P greater than Q. 2 alpha hydrogen, and this is 7 alpha hydrogens. Clear? SR, P, Q. Now coming to question number 15. Now it is stabilized by resonance and it is stabilized by hyperconjugation. So how many alpha hydrogens are there? So total 9 alpha hydrogens are there. So your answer is resonance dominates over hyperconjugation. Stop. So this is exceptional one. Okay, this is exceptional one. So you have to remember this one. So here it is 9 alpha hydrogens are there. So if 9 alpha hydrogens are there, so because of that more number of alpha hydrogens, so number of hyperconjugative structures are more. So therefore it dominates over resonance. So this is only one exception. You can take it, and another exceptions are there, but basically we focus on these particular examples. So here Q greater than P, and here hyperconjugation dominates over your resonance. Hyperconjugation dominates over resonance. Okay, question number 16 there. Here in this case resonance there, here in this case hyperconjugation, 9 alpha hydrogen. Yes, correct. So hyperconjugation dominates over your resonance here. Okay, now question number 17. Now this carbocation stabilized by dancing resonance, and this carbocation having aromaticity, and this carbocation is showing this question is a little bit wrong. Yes, it is like this. Okay, forget about this question. Okay, so this is R. So you can see here this is stabilized by resonance, and you know that dancing resonance dominates over aromaticity, aromaticity dominates over your resonance. So the answer is Q greater than R. I hope you like this video. So thank you very much for watching Chemistry Pathsala. So keep watching. Thank you very much and happy learning.